briefly introduce about solarEdge as a company. So I think most of you must be aware, like solarEdge is an Israel-based company. So our headquarters is based out of Israel. And if you see the solarEdge as a company, we are number one in position. As a market position, we are number one. This is as per 2019 results. And we have direct presence in 28 countries. And more than 2,400 employees are there in our organization. Until December 2019, we have shipped 16.2 gigawatt of inverters globally. And in terms of sites that gets monitored in our site is more than 1.38 million project sites are getting monitored in our monitoring portal. And in terms of revenue, last quarter, that is Q4 2019, we have closed with $418.2 million US. And for the whole year, that is 2019 whole year, we have completed or we have closed with greater than 1 billion as a revenue. And in terms of patents, if you see, we have more than 348 patents in our solarEdge name, and another 266 are getting pending. So that way you can see solarEdge is very technically a strong company, and we are also financially a very strong company. So that's in brief about company as a company. And coming on to the R&D and manufacturing facilities. So we have 3 R&D centers, Israel, Bulgaria, and California. So these are the 3 main R&D centers that we have. And coming on to the manufacturing facilities, we have 4 manufacturing facilities, main based out of China, and then the Vietnam is a new plant which came operational since 2019, and then we have in Hungary and then Korea. So these are the 4 manufacturing facilities that we have. So now let me introduce about our group companies. Okay, so before getting into the group companies, as I told, you can see the market, how solarEdge is growing year on year. So in 2017, in market position, we were in 10, and 18, we moved to position number 4. And in 19, we came on to position number 1. So you can see clearly how solarEdge is growing year on year. And just to give an idea, almost every year, year on year by 40% we are growing. So that's our growth rate. So we are consistently growing, and that's one of the reasons why you can see solarEdge is becoming more and more strong company. So let me now introduce the group companies. solarEdge, initially we started mainly focusing on the grid-tied inverters. Of course, we have a different technology, DC optimized inverter technology. Now solarEdge is also moving beyond PV. So one of the first acquisition that we had was an UPS company called Gamatronics. So Gamatronics, once again, is an Israeli company which started in 1972. So they are very strong in UPS division or UPS product, and solarEdge has completely taken over that company. So we will be mainly concentrating on the commercial products, that is starting anywhere from 10 to 500 kilowatt of products that we will be concentrating. So the next major acquisition that we had was Kokam. So Kokam is a South Korean company. So they are based out of South Korea, and they are very strong in manufacturing lithium-ion batteries. So in fact, Kokam is one of the top 5 companies who manufactures lithium-ion batteries. So they are very strong in ESS, that is in large-scale energy storage solutions. So solarEdge has completely taken over this company, and apart from large ESS, Kokam is also good in having solutions for EV, marine applications, and military and defense. So they have various products for various applications. Of course, their main strength is on the ESS, and solarEdge has completely taken over this company now. And the last acquisition that we had was an Italian company called SMRE. So SMRE is a company who focuses on the vehicle automation. So they are mainly focusing on the vehicle automation, and now their main focus is on the EV segment. So where they have the completely innovative and high performing power trains with the gearbox, engines, battery, and the BMS. So as a solution, we can give to the oil company so that they can build their product based on our solution. So that's the strength of SMRE. And of course, the battery comes from our group organization, Kokam. So that's in brief about our company and the group divisions. So now let me get into the technical part. How solarEdge is different from other technologies and what advantages we are bringing in terms of technology. So before getting into that, I would like to quickly touch upon what are the limitations that we have in the current technology. So once we are clear on what are the limitations that we have, then it will be easy to understand how SolarEdge is overcoming those limitations. So what we see in the screen now is an IV curve. So if you take any PV module, so every PV module will have an IV curve, nothing but the current and the voltage curve. And every PV module will have its unique MPP point, that is maximum power point. So when we have a module from the same manufacturer, even from the same batch, so there is no guarantee that all the PV module will have exactly the same MPP or the maximum power point. So when we connect the modules in series, what happens? So even if one module is not performing up to the mark or up to the expectation, then the entire string performance gets impacted. So this is what we call exactly as a module mismatch. So one of the main reason for the module mismatch is, if you see today's inverter technology, the MPPT, that is a maximum power point tracking algorithm or maximum power point tracking softwares are being implemented at the string level. So since each PV module will have its own MPP point, the MPPT or the inverter cannot operate at a different points. So they will try to find an optimal point. So in this process, if even one module is underperforming, then it will impact the performance of the other module in the same string. So as we can see in this screen, so we have connected 4 numbers of 250 watt peak panel. So ideally or theoretically, all the panels are supposed to produce 250 watt peak of power. But for various reasons, one of the module is not producing 250 or it is producing only 242. So because of this particular module, the third module, the other 3 module MPPT point also is being compromised. So we can see here, even though the other module can produce something around 250 or 248, because of this 242 module, 242 watt peak module, the other modules also power is getting compromised. So this is what exactly we call it as a module mismatch. So module mismatch is nothing but is equal to the power loss and the energy loss. And if you see what could be the sources for this module mismatch, so the sources can be any of the sources what we are seeing in the screen. Either it can be because of the transportation damage, or it can happen because of different tilt and orientation, especially in the rooftop. And thermal mismatch. So when we talk of thermal mismatch, once again, this mainly comes from the rooftop project, especially in the flush mount type of rooftops. So where the outer rows of module will have sufficient air cooling, whereas the third or fourth row of the modules will not have the same amount of airflow, so that the operating temperature of those module, inner row of module, will be different compared to the first row of the PV module. So because of this difference in operational temperature, the thermal coefficient will vary. Obviously, the power output also will vary. And of course, everybody knows shading and soiling also contributes a large to the module mismatch. Even a couple of modules are shaded, or if a couple of modules are under heavy soiling or dust, then that also will contribute to the module mismatch. And of course, manufacturing tolerance also contribute to the module mismatch. And the last and the most important thing, if you see, for the main source for the module mismatch is the uneven module aging. So if you take any of the module manufacturer, they would have given a derating curve or a derating factor. So this is how they will be claiming the module will be derating. But actually, if you see in the ground reality, the module aging or the degradation doesn't happen uniform. So even though the module manufacturer claims the module degradation from second year onwards will be at 0.5%, but in ground reality, it will not be exactly 0.5% for all the modules. So some module may be degrading at 0.7, some module may be degrading at 0.5, and some good modules may be degrading at only at 0.3. So because of this uneven degradation, this also further contributes to the module mismatch. So that's the reason exactly if you see any power plant which is aged or which is older than 2 or 3 years, we can see the power generation will not be the same like what we saw in the first year. So this is because mainly of the uneven module aging. So just to summarize, if you see, these are the 4 major limitations that we have in the current technology. So the first limitation is the energy loss that happens because of the module mismatch. And this module mismatch mainly comes because of the MPPT at the string level. Because today, if you see, traditional string inverters having MPPT at the string level only, they cannot do a MPPT, or they cannot have a MPPT at the module level. Because of that limitation, the module mismatch becomes unavoidable thing. So obviously, because of module mismatch, we have a lot of energy loss. So that's the first major limitation what we have. And second, if you see in terms of design also, we don't have much flexibility in terms of design. So we do have a lot of constraints in the design. So when we say constraints in the design, like first important thing is we cannot put the modules under shadow region. We cannot mix the modules of different tilt and orientation, at least to the same MPPT. So we cannot mix and match the modules of different ratings or different technology to the same string or to the same inverter. We cannot have long string length. So like that, we have a lot of a lot of constraints in the design. And third limitation is the resolution of the monitoring. So let's assume that we have invested 100 rupees in a power plant. Out of 100 rupees, 50 or 60 rupees goes for my PV module thing. But we don't have a mechanism to check or to have a detail how this PV module is working. So all we have is only up to the inverter level, or sometimes some of the inverter manufacturer gives up to the string level. But beyond that, actually my generating source is a PV module, but I don't have a mechanism to check or monitor how this PV module is working or functioning. So in a power plant, even if it is a 10 kilowatt power plant or even a 5 kilowatt power plant, even if one or two module is not performing to the mark, then the energy generation loss will be very high. So, and today we don't have any mechanism to check whether the PV module is healthy or not. We don't have a mechanism. So that's the third limitation. And last is the safety hazard. So here we are trying to focus on the DC side safety. So if you take any regular inverter technology, moment we turn off the inverter or there is a grid failure, the inverter safely gets isolated or it gets anti-aliasing mode, and then it gets disconnected from the AC grid. But what happens on the DC side? Still we are dealing with a high DC voltage. And especially this becomes really a dangerous thing whenever a person is going for a maintenance activity. He turns off the inverter, but on the DC side, he's always having a risk of getting exposed to the high DC voltage of 800 volts or 900 volts. So these are the four major limitations that we have in the current technology. And now let's see how solarEdge is addressing this limitation and how we are overcoming this limitation. And apart from overcoming this limitation, let us also see what are the advantages we are bringing in terms of technology. So if you see a regular inverter topology, it looks something similar to this what we are seeing in the screen. So we'll be having a PV module connected in series, and then we'll be